Okay, so in this one we will be talking about the adapter design better, where we are using this when you have an existing class that does not match the interface expected by some sort of another class. So mainly you have two classes, right? And the one class actually implements an interface, and one there's another existing class. You want to use that class inside this new class. So imagine a scenario, you have some sort of a legacy code, right? And then you have some sort of a new code, a new set of functionalities, and a new set of uh, client code, but you want to use that legacy or older code or other existing classes inside this new set of classes, right? Think of it like that. Yeah, so mainly you want to use the functionality of existing classes inside new set of classes. And the thing is, this new set of classes have implemented an interface, and it does not match the older or other existing classes. So that is a problem. So we need to solve it. As the solution, we'll create an adapter class which implements the expected interface, right? And inside the adapter, we'll use the legacy or the older class to call the functions or call the methods within that class, within the adapter class. So we are not using the newer or other new classes that we want to use. We are just using an adapter. We are calling the older code, right? Then in the new classes, we can use the adapter to uh, use whatever the code that are specified in this older or the existing code. So adapter is like a intermediary, sits between old and new classes, legacy classes and new classes, right? So if you, when we go to the demo, you will understand. So adapter pattern allows the interface of existing classes to be used as another interface, making it compatible with different client code. So it is sort of a making older classes or existing classes compatible with newer classes or some other set of classes. Basically making older classes compatible with some other classes, right? So it is like an adapter, as the name suggests. Think of a this sort of a travel adapter. So you can have various kind of plug points in your hotel room, but your mobile phone or laptop might be using different kind of a charging pin. Then what happens is you will have to use this kind of an adapter to convert your wall socket type to your mobile phone charging port, because otherwise you will not be able to charge your mobile phone while you are traveling, right? So same thing, let's try to implement it. So this one, assume in this case you have a um, you have two different types of laptops, okay, and one from Europe and one from America. The problem is European laptop can only charge using European plug, right? And the American laptop can only charge using American plug. But what if you have an American plug and you want to charge the European laptop, right? So thing is, now you have two different types of laptops, European laptop and American type laptop, and you have a American plug only, right? But you want to charge the European laptop. You don't have a European plug because you might. be left it somewhere, or you forgot it, or you don't have one, right? So you only thing you have is a American plug. So how to charge your European laptop using this American plug? So that is our problem. So here we have this European laptop class. So it is like the European laptop you have. It has a method called charge with European plug, which means it can only be charged with a European plug, right? So that is European laptop. Then we have an interface, I American laptop. This is the target interface. This is like the special rule book, right? As you know, interfaces define what should be implemented when this interface is implemented. So it is like a rule book that says every laptop should be able to charge with American plug, right? So it says uh, every laptop should be charged with an American plug. So imagine you have traveled to America, but you have not. I mean, you have brought your European laptop to America, and you have an American plug, right? There. So inside America, every laptop should be charged with an American plug. This is the American rules, right? And you only, I mean, you have taken your European laptop to America, so now you have a problem with this rule, basically. So they have a rule calling, saying every laptop should be charged with an American plug, right? Now let's create the laptop adapter. Let's create an adapter. This is like a clever device, like the one I showed you earlier, that helps your European laptop work with American plug. Now this adapter will help you to charge your European laptop. Basically call this method, right? Charging means calling this method inside the European laptop. Um, so this laptop adapter will help you to do that. Charge your European laptop with American plug. It is like an adapter. So you see in the as I showed you, travel adapter. So different kind, it should be work with different kinds of plugs, right? So it let's try to implement this. How to do this? Uh, let's first of all implement this American laptop now, because we have to follow this rule. Because we are in America, right? So if you are following this rule, uh, this one, we need to implement this one as well. But first of all, let's take the European laptop as a helper, right? So to charge charge the European laptop, I mean, you have to connect it to the laptop adapter, no? Otherwise, how you can charge the laptop? So let's connect it. So to connect it, we'll create a variable here, private European laptop, and then we will pass the same European laptop as a constructor parameter here. This is not dependency injection, because we are not passing an interface. We are just passing the concrete class, right? So it means we have to pass an object of a European laptop to work with this laptop adapter, right? So here we are just trying to get an instance of European laptop, so that this laptop adapter will work correctly, because adapter means it should connect to a device, and the other side should connect to the plug, right? So you have brought your European laptop to America, so therefore you have to create an adapter which should follow American laws, right? And to connect this laptop adapter to a laptop, you will have to provide your laptop as well. So that is why it is saying we are passing this European laptop as a parameter. So it is like a helper or a friend, right? And then let's set this existing variable from the parameter that we got from the constructor. Now let's implement this charge with American plug, which is this method, because we are implementing this interface, or in other words, we are in America, we need to follow this rule, so we are writing this method here. So let's provide an interface. So since now we have access to European laptop, we can straight away call charge with European plug. When we call charge with American plug, our adapter will call charge with European plug inside charge with American plug. So for to an observer looking at this from somewhere else, they don't know whether we are using European plug. They will see we have a public method calling charge with American plug, but within the class itself we are using a different object or different class or European laptop to charge this, right? So we are calling this will be our special rule that we need to implement to because we are in America. Then we call charge with American plug on the adapter. It takes the European laptop and tells it to use the European plug, by calling charge with European plug. After that, we can say I have just converted this plug to American plug. Adapter is converted to American plug. So with this code, you can use laptop adapter this class to make your European laptop charge with American plug, right? Even though it was originally made for European plugs, right? So European plugs, so this laptop was made for European plugs. But what we have done is, since we are with every class should implement this interface, that is the purpose of an interface. So interface has this charge with American plug method, right? So every time you in a class, when you want to charge something, you have to charge it with an American plug. So our European laptop may not work with American plugs. So therefore we have created an adapter. It is implementing this rule set or other interface, American laptop. So therefore we need to provide an implementation for charge with American plug. That part I think you understand. Now what happens is we are expecting the European laptop as well, because obviously we have created an adapter. So adapter one side plugs to the wall and the other side plugs to the device, right? So this is the device that we want to plug into this adapter. So we are passing this device as a constructor parameter to this adapter, and then adapter takes care of how to charge it, right? You can change this implementation anyway, but what happens after this is totally up to your control. But the thing is, we have used an adapter class to call an existing method, existing class, right? Existing class method using an adapter. So this is how we are implementing adapter um, design pattern. Let's try to use it as well. So first of all, we'll create an instance of European laptop, because we need that to pass it as a constructor argument to that adapter. Right now, let's create our American laptop using the laptop adapter. So we are passing, as I mentioned, this European laptop as the constructor parameter to this laptop adapter. So our American laptop has a implementation to charge this laptop, charge with American plug. Right, that's it. We have European laptop, and we have created the laptop adapter using that European laptop, right? Because maybe laptop adapter is looking at the European laptop to understand what sort of a plug it is using mainly. I mean, basically what it does is that, right? It asks for a parameter. Otherwise, how can we call this charge with European plug within this new class? We need to have a reference, object reference to this European laptop, right? So therefore, we have created it, and we have uh, passed this European laptop um, object to this laptop adapter. Now we can use this charge with American plug inside this laptop adapter to charge our American laptop. So that is the main idea behind this. So as I mentioned, adapter design pattern mostly is being used uh, when we want to integrate older code legacy systems with new systems, right? When you want to reuse or use an old set of functions, so maybe methods within a legacy code base, and if you want to incorporate that legacy functionality into the new functionality or new system, then we can use adapter design pattern. So we can utilize the legacy functionality into our new application as well. So let's try to run it as well then. So it says that now it is charging with European plug. The American laptop is charging with European plug. Right? So we are not calling any method inside European laptop, right? Look at this clearly. We are not calling any method of European laptop charging with European plug. We are not calling it here. We are just creating an object, and the adapter calls that method. So therefore, our American laptop is now charging with European plug. And also we say that since this is an adapter implementation, adapter converted to American plug, we can do whatever we want in this. Otherwise I just added the console right line so that you guys know that we can do anything here, right? You can do whatever anything else you want. If imagine if this charge with European plug provides some sort of a return, it returns some sort of an data or a result. If you want to do something with that result also, you can do it here, some modification or something like that, and you can maybe apply some sort of a function on that and return some other data based out of the return result of this one. But we don't want to do here because it will make things complex. But as you understand, right, charging now we are charging with the European plug because we have converted our adapter to the American plug. So that is the uh, adapter design pattern. So what we have done essentially is we have allowed existing classes to work with new client code without modification. We haven't modified anything in the European laptop. We have just uh, created an adapter, so it enables interoperability between different classes and systems. But it can introduce an additional layer of complexity in the code because we are creating any of these adapter classes and all. But also it may require creating multiple adapters for different classes or different interfaces as well. So the summary is it introduces additional overhead and complexity to code, right? It, as I mentioned, it acts as a intermediary between two interfaces, so two classes. Maybe one can be a class and the other can be an interface, which means it must perform extra operations, right? It have to perform some extra operation to convert data. So in our case, we don't have any conversions, but as I mentioned, we can have some sort of a data conversion logic here as well, based on the return data of this method, right? So if that is the case, we need to handle exceptions, delegate calls and things like that. So yeah, there are some trade-offs, but the problem it solves is much greater than the problems it has. So as per all the other design patterns, there are some trade-offs, there are some good things, there are some bad things. So depending on your problem and the solution that you want, you can decide what is the pattern that you want to implement, right? And everything else, just like these trade-offs and issues it has, you have to handle. If you see that there are some other operations that you need to perform, you have to do it and you have to handle that exception. But the benefit that you gain from adapting, I mean using adapter or rather one maybe one some other design pattern also is much greater than the issues that you are facing by implementing it. That is why we have these design patterns. Okay, let's move on to the next one then.